Hi, this is Paul Namuag, Support Engineer of Severalnines. In this video presentation, we will discuss about how to manage your application failover or switchover process for MySQL, MariaDB, and PostgreSQL. Our topic covers the introduction to failover and switchover, covering MySQL, MariaDB variants, and then PostgreSQL. Why do you need to automate it or when you don't need to automate? Understanding the failover and switchover. Orchestrating failover across the whole HA stack. Common problems encountered where failover has to happen. From assisted environment, implementing the full automated failover with cluster control. So what is a failover? When to failover and how? First, what is a switchover? Switchover is the process of switching a master role to another server through the process of slave promotion. The actions are planned. A common example is when promoting a slave to take over as the new master. Certain situations you need to do that is when the current master has to undergo maintenance like upgrading the software or hardware, and so it needs to be taken either out of the cluster or assign it as a passive database node. While failover is more automatic and doesn't need a human intervention, it is similarly has the same process as switchover, but it's more applicable for scenarios when an error occurs or a failure on the current active node or master database node and doesn't need any human intervention. It acts based on the defined procedures or hooks when this process are triggered. Its worst case scenario is that when you cannot assume all the slaves are in sync. In continuation of the failover, it is performed when the old master became unavailable, such as due to a hardware failure or system crash. Both in MySQL and PostgreSQL replication rights have to be sent to the master, therefore its crash affects the whole cluster, making it not available. What is more important is that you should be able to verify the master connectivity from the point of slaves. For example, it may happen that the monitoring node cannot reach the master while slaves are happily replicating from it, so it's a false positives. Failover should be triggered only if the master is indeed not reachable neither by the application nor by the slaves. It has to be a valid case and to avoid false positives and premature failovers. Now the question is, how shall a MySQL process the failover? So here's a list of how the process of failover can proceed. After a master crash, you end up with one or more slaves. Then after the master is indeed not reachable, decide which slave is the most up-to-date and pick it as a master candidate. Ensure that there are no errant transactions on the master candidate. Collect missing data from the master if it is possible and replay them to the master candidate, or do a PITR as an additional step. PITR is a point-in-time recovery. Reslave all remaining slaves of the new master. Ensure to the best of your abilities that the old master will not be started again before it can be investigated, such as implementing stunith or shoot the other node in the head, or implement member fencing scripts. Rebuild the old master as a slave using the data from the new master. Now for PostgreSQL, the failover mechanisms shall have the following procedures. After an active server crash, you end up with one or more standby servers. Verify that the active server is indeed not reachable. Find the most advanced standby server. Trigger the failover using either pg_ctl promote command or the trigger file. Run pg_rewind for remaining standby servers to make them in sync with the new master. Slave remaining standby servers to the new master. Ensure to the best of your abilities that the old master will not be started again, such as implementing stunith or adding fencing scripts like the MySQL procedures before you investigate this node for RCA or root cause analysis. Rebuild the old master as a slave using the data from the new master. So next is a question of failover. Does it need to automate or unautomated? For some certain situations, failover which has to be automatic can be tweaked or violated in a way that it does not need to be fully automatic or automated. From the last two slides, the failover requires a couple of steps to be performed. As usual, more steps and more complex they are, the higher chance for human error. Scripts can easily perform all the tasks required, run all the checks, and do it way faster and more reliable than human can do. Scripts are written smartly and intelligent, but in some situations, human can be more flexible to handle situations. For some situations, as well as requires human to intervene to witness the problem and act accordingly based on the current state of the problem. The script might not foresee that and not able to deduct its reasoning on what's best thing to do. Should we automate the failover or not? That's the question. Let's go through some pros and cons of automated failover. The pros: way faster reaction on the issue, has a chance of committing lower downtime and improve your recovery time and recovery point objectives. Higher reliability for typical situations when configured correctly may handle majority of the cases in a proper way. Reduce on-call burnout even though you page your staff. It's not as critical given the systems are up and running. The cons. So, limited situations awareness does not understand the large picture or understand what has been coded in. Decisions made are not always correct. Comes with surprises that script not able to cover, hence creating a possible long downtime that should be avoided. Requires intensive tests to ensure reliability. Has to be maintained if it's your own script. In continuation for the automate or not to automate, the main differentiating factors are the reaction time and lack of situation awareness. Automated failover will be faster but may take actions user would not take. Logic can be improved or add more safety or fencing like whitelisting or blacklisting in attempt to reduce incorrect behavior. Better visibility can also be implemented. Access tests through multiple hosts, slaves, proxies. Utilizing clustering protocol like Raft or Paxos for network split detection. Don't expect automated failover to cover correctly 100% of the cases though. Third, way may also be applicable. Assisted failover does everything automatically but is initiated by the user after the initial assessment. So next is understanding the switchover process. So in this section, the switchover process content coverage are up to the most common implementation processes only when promoting a slave or demoting a master. So in this video session, it focuses more of the failover scenarios, but we'll tackle switchover as well. So for MySQL, the switchover is a planned action. So its main common actions to take this process are place the slave under maintenance mode. So you have to relax the proxies because if you don't do, some proxies detects changes on the SAM state of the nodes and reacts accordingly like PostgreSQL. That might damage the cluster if you forgot to relax it prior to the planned action, then so as the master and its underlying slave nodes. Ensure master is no longer active. Ensure master is still on write capable node and target slaves are on read only or super read only unless overseen before undergoing the process. For GTID based replication, compare the master UID from slave status to the target slaves against the server underscore UID of the master. Check the target slave, check which is the target new master for errant transactions to avoid consistency or data drift. So a warning prompt can serve as a notification to the user to avoid further damage of the data in the cluster. For example, notify before continuing a certain action or let it fail and manually fix it. Check if all logs are applied in the target slave. Otherwise, let the slave catch up for unapplied transactions from the master. For the non-GTID replication, compare master log file and combination of exec master log posts from the slave status of the target slave against the bin log file or post combination result on show master status of the master node. Check the seconds behind master with the reinforcement of values from the two parameters mentioned above, so the check would be more accurate. If binary logs are found with or without no corruption, then continue to catch up until slave log is 0. Otherwise, let it fail because you cannot continue binary log is no longer found, such as removed or moved elsewhere or was reset. So then when it's ready, reset the slave info detaching any slave code replication configuration from the target slave, which is actually the supposed new master. Add the slave user or password host and its grants with the old master and or other slaves which will be used for establishing a replication connection. Set the new master read only and super read only equals to 0 which is to be a writer node capable, and the old master set it to be which is now actually demoted as only a reader node. So point the old master and point the other slave nodes, if there are any, to the new master, appointed master. And then do not forget to repoint VIP proxies or updated DNS if you're relying on it. So application client endpoints will not be changed, but will use the same endpoint, but it points the newly promoted master. Still same with MySQL. For PostgreSQL, switchover is planned action, as the common actions to take this process are: place the cluster under maintenance mode, relax the proxies, master and its underlying slave nodes, ensure master is no longer active so it won't process any writes. On the standby or target node, which is to be promoted, promote using pg_ctl promote command or with trigger file from the recovery.conf or the PostgreSQL asterisk.conf file, since pg12 doesn't support recovery.conf. Run a pg_rewind to the demoted master and to other remaining standby servers, if any, to make the data directory and configuration files in sync with the new primary. Create the recovery.conf or recovery.signal and standby.signal if you're actually using PostgreSQL 12. Change the primary underscore con info to the recovery file or in the pgconfig if it's actually PG Postgres 12 version. On the standby servers, that includes the demoted primary to the new master, and of course starts the servers accordingly. So we in this section will be understanding how does the failover process. So okay, when failover is about to happen, you must have to ensure that the master is sure it's down. Master has to be critical, so avoid any false positives or premature failover. You never want to run two writable masters at the same time. This scenario has to be avoided. You may want to implement some sort of fencing like Stunith, as what I mentioned earlier, shoot the other node in the head to ensure that dead master will stay dead and will not come alive, or because you'll end up two nodes writing at the same time. You can leverage data from multiple sources. Are slaves replicating? Do proxies see the master? Next is pick the correct slave as the master candidate. Picking the correct slave as the master candidate is critical. You want to use the most advanced slave or standby node to avoid data loss. For MySQL, you want to ensure there are no errant transactions in GTID setup. You want to allow the slave to apply the events from slave logs as long as it does not take too long. You want to try and reach the master to see if there are non-replicated binary events. Just for the last part here, master failure does not always mean you cannot SSH there and parse bin logs for missing transactions. Next is correct usage of whitelist and blacklist. Correct usage of whitelist and blacklist is critical. You may not want to promote any slave if you have better to stay with the same data center to avoid split brain scenario with two masters. Better to stay with the same data store version for compatibility reasons. Better to stay within the same hardware for performance reasons. While executing a failover, use the standard procedure for making master and slaves. Read only and super only has to be 0 or 1. So that has to be considered. For some situations or special cases, pre and post actions might be done before and after the failover will proceed. So there's a need for pre and post failovers actions. For pre and post failover actions, automated failover process can sometimes be augmented by the use of pre or post failover actions. The useful implementation is that these pre and post failover are bound to scripts which can be hooked by the failover tool or software. So you have questions to cover for your pre and post failover scripts as Do you want to perform some actions when the master fails? Do you need to reconfigure some application when a new master is promoted? Do you want to remove old master entry from your console key or value store if you're actually using console as a service discovery tool? Then most of the main tools that support failover handling support also pre and post failover actions such as MHA, Orchestrator, or ClusterControl. Next is orchestrating failover across the whole stack. So databases do not exist in a vacuum. They are surrounded by other services to create a highly available environment. The proxies need a way to distinguish between the master and the slave. In PostgreSQL streaming replication, this is typically the existence of recovery.conf or recovery.signal since Postgres 12. In MySQL, it can be, for example, a value of read-only and super read-only, either 1 or 0. When failover is happening, you have to make sure that you manage the variables value correctly. You don't want to load balancers to send the traffic to your databases while failover is happening. For example, as shown here, for HA proxy, rest assured the read nodes are only available on port 5424, while the read node, which only the 10.00.126 node is available for up state, can be accessed at port 5433. In this screenshot, PostgreSQL separates the writer versus the reader nodes based on the host group. As you can mention, all load balancers deployed by ClusterControl follow those rules. For PostgreSQL, recovery.conf, since PG12 or recovery.signal and standby.signal, since as what I mentioned, since PostgreSQL 12, for MySQL, it's read-only value. ClusterControl ensures that the values MySQL are defined accordingly to the stage of the process. In switchover, the master is demoted through read-only equals to 1. In failover, this cannot be done. Still, read-only is equal to 1 is configured in MySQL configuration on all nodes to minimize the chance of old master returning as writable host. New master is marked with read-only equals to 0. This process works but does not cover all the situations, so you have to take note of that. So next, what are the difficult problems you can face on failover? One is network issues. Networks can be unstable and packets may be lost during the transfer. Replication itself is robust and it will work quite well even if there are network problems. Health checks performed over the replication also have to take such conditions under consideration. Make sure you do not take any actions based on a single health check. Make sure you do not take any actions based on a single host point of view. Expect network problems and try to understand their severity before an action will be taken. Another is network split. Or network partition. Every cluster type has its own problems. For example, in MySQL and PostgreSQL replication cluster, one of the biggest issues is the lack of cluster awareness and lack of quorum support. Replication clusters are prone to the network split issues, especially if nodes are spread into different regions. Automated topology detection by proxies can make things even more tricky. There's no easy standard to avoid this problem. Network split can happen also when there's a lack of connectivity between one part of the cluster and the other part. For example, the master cannot reach the slaves cannot reach the master, so there's a network instability. Master is unavailable, therefore cluster cannot handle writes. Failover should be performed to restore cluster ability to handle traffic. Master is still running, but when networks converge, two writable hosts will show up, so ends up with a split brain scenario. Standard topology detection logic will not be enough, so two nodes will have read only equals to 0 for MySQL. That means two nodes will end up being writable. Two nodes will not have the recovery.conf or recovery.signal and standby.signal fast for if using PostgreSQL. Without additional measures to ensure the old master won't get the traffic, a split brain is imminent. So as we have mentioned earlier, another difficult problem to handle is with split brain. Split brain is a condition in which two writable nodes take the traffic and as a result their datasets drift apart. There's no easy solution to recover from such condition. Shut down rogue master as soon as possible to minimize the data drift. Manual action will be required to converge the datasets. Make sure that whatever solution you chose, it works. One thing to add, if it interests you, GitHub had a major catastrophe about split brain or network partition had occurred in their database environments. Well, you can search this in Google and you can learn how to avoid these kinds of problems, which definitely has to be avoided as possible. Um, Lastly, in this illustration, a particular scenario where at first one master serves as the writer node, then experienced a failure, and on the second image, the old master was taken out of the cluster. Hence, the new master takes over, but then on the third image, like it can happen for a few seconds, the old master came back but the proxy server identifies two master or writer nodes. This case scenario can cause data drift within a particular database cluster. So how to avoid them? There are numerous ways in which you can reduce but not to avoid the impact and probability that your data will be affected by network issues. Collect as much data about the state of the replication topology before an action is taken. Utilize multiple nodes as the point of view on the topology. Try to implement Estunith or fencing mode scripts to reduce the chance that old master will show up. Some kinds of lights out solution or ILO, for example, might work for a physical environment. This is very common. For example, the those servers, those kind of servers, powerful servers. Um, Kill scripts destroy given virtual instance may work on the cloud. Modify configuration of the proxies to remove old master after it's deemed as dead. No solution will be 100% bulletproof. You may not be able to reach all the proxies, the node itself, or cloud server to kill the master.